Algebraic inputs and outputs have a huge role to play in scientific research and in modern artificial intelligence through algorithms. They don't have to be this abstract, complicated concept. You can work on your algebraic understanding simply by engaging with problem solving, critical thinking skills. And if you think that algebra is all about x's, y's, and ABCs, you may not be aware of how algebra has a story connected with the story of humanity's history, or why it's so important. Even the origin of the words algebra and algorithm have an origin that might surprise you. They both come from the name of the titan in the thumbnail. Maybe you know him, maybe you don't. He's called Muhammad ibn Musa al-Khwarizmi, and he is the so-called father of algebra. The discipline of algebra that this ancient savant developed takes your skills of understanding and relating quantities to one another to the next level and applies that logic to any problem governed by the same rational principles. It is incredibly powerful, and if you don't know what I mean by that, we're going to interrupt this regularly scheduled maths video to jump over to history and economics and consider the curious case of Henry Ford. But before we do that, folks, welcome back to GCSE Minecraft and Chill, my series where I play Minecraft while I entertain myself and maybe you with the stories behind the science and maths that you need to revise that fascinates me. I hope you're having a relaxing day and that you've got a cozy, warm, or refreshing cold drink and something to do while I chat and build. I'm just going to be here decorating my house and my roof while we learn about some algebra. And don't worry, there's no equations in this video, just some food for thought and a story of two seemingly unconnected old dudes from history. So let's get into it and first talk about Ford. Henry Ford is a fascinating historical figure. I first learned about Ford at school during my history GCSE when studying modern American history. I recognised the brand name Ford from the cars, right? And learned and recognised that something about his factory production line was important to the American or global economy or something, but didn't learn more about him beyond that or appreciate what a massive figure of the early 20th century he was and the devastating legacy that he has left behind. So do not mistake my inflation of his impact on the world for respect, and I really don't want to spend any longer than necessary on this historical figure known for his vicious anti-Semitism and delusional hatred and hypocrisy. For example, he made massive technical contributions to both sides of World War One and Two with his vehicles, despite being vehemently against war and those that profit off of it in particular, and then turned around and exploited French prisoners of war for enslaved labour. What? And he did this while at the same time having the goal to be anti-union because he believed in the right of the working class to have leisure time, higher wages, and more economic power, which is good, but because that led to higher productivity. And he believed that union leaders themselves profited off of economic crises that affected the working class. Bit of a complicated opinion there, but clearly the working class that he represented only included a certain group of individuals and not the everyman that he claimed to represent. So, to be clear, we don't like Mr. Ford. And when I say that something is fascinating to me, you have to understand that that does not necessarily mean in a positive or flattering light. I'm not talking about what this guy did or believed because I like him. And if you think that his philosophies and his impact in the early 20th century sound familiar, almost like another very famous historical figure of the 20th century, you'd be correct. He was very well liked by the infamous cult leader of genocidal Germany in the 1930s and 40s, and they shared values and beliefs. And we can acknowledge the impact and complicated legacies of influential historical figures like this without ascribing any moral value to our interest in understanding them, provided that we are intentionally engaging with the information and reflecting on our interest in these figures critically. So for me, challenging cultural norms and narratives around revered historical figures like this, whose positive achievements and impacts often outshine the more balanced view of their legacy, is something I actually care about, particularly when the figures are associated with my fields of expertise. The context surrounding why and how these individuals had power, what they chose to do with it, is crucial for critical thinking and learning how not to repeat their mistakes, right? You just sometimes have to have a very strong stomach to read about most, in fact, of the powerful and impactful figures in history. Mostly they are all terrible. So actually, while we're at it, here's a tangent for you. I've got no interest in knowing or judging whether an individual from the past was good or evil. especially if I'm only assigning the value of me reading and learning about them based on that judgment, but also because good and evil is one of those pernicious false binaries of the world that serves to hoard power and resources to whichever group society is able to successfully convince everyone is good, right? And then therefore justify stealing from or committing violence against whoever we deem evil. And it's only a hop, skip, and jump before we're duped by the propaganda and our beliefs are aligned with the genocidal values of the likes of Ford, Hitler, and Netanyahu, for example. So I think good and evil is one of the worst binaries that exists in the world that we all need to deconstruct and unlearn. But you might think, well, you just described some really awful beliefs. Surely you think that Ford and others like him are evil. And to that I say, I don't think that people can be fundamentally evil, only incredibly harmful and possibly misguided and shaped by the beliefs of the world around them and what it promotes, normalizes, and rewards. And that's actually why I think it matters that we don't use these false binaries and binary language like that when it comes to people. Um, we can use it to describe acts or impacts or whatever, but not people. But that's a topic for another video. Tangent over. Why am I talking about war and the economy in the 20th century and Henry Ford and what his beliefs were? So let's get back to maths with all those disclaimers and philosophical musings about good and evil out of the way. So Ford's notable achievement that often whitewashes his abhorrent belief system and behaviours is his novel development of the production line, like I mentioned. Ford was known as a child for having an insatiable curiosity for how mechanical things like watches and eventually engines worked. He liked to take them apart and put them back together, and he liked efficiency. Very relatable for a scientist. Out of this, and because of the algebraic thinking that he applied to the steps, components, and processes involved in the construction of engines and cars, the Ford production line was created. And I want you to understand this because Ford could not have conceived of this production line system, which had massive impacts in the 20th century and the world we live in now and the world wars, if he had not both understood the steps of the mechanical construction and thought about them in an abstract way that allowed for generalization of each step into a sequence of repeating parts that could be done by one pair of hands on one part at a time, right? This is a world-changing shake-up in how modern factory lines work, and it made cars financially accessible to the general public, the mass population. And think about how that process has been applied since to almost every mass-produced items that we purchase, use, or consume. This was such a big deal, um, and I can't emphasize that enough, because think about for a sec about what I just said, right? He generalized each step into a sequence of parts that could be tackled one at a time. And then remember that the topic of this video is algebra and algorithms. Does that not sound like an algorithm to you? Ford basically reinvented what Muhammad ibn Musa al-Khwarizmi did in the 9th century and applied it to the process of building engines, cars, planes, and whatever. He made the construction process an algorithm that individual workers could follow, and now in modern times robots can follow, right? Because of his deep understanding of the exact steps involved and how they all connected and made the most efficient production line. This is logical lateral thinking and abstract algebraic conceptualization married together that al-Khwarizmi applied to solving equations, polynomials like quadratics, and other common math problems of his time. And what that did is develop an incredible toolkit for algorithmically solving almost any problem, just like how Ford applied this tool in his thinking for solving the problem of how inaccessible and expensive cars were to produce for the average American. So finally, we connected the two men, and I'm now going to pivot and talk about al-Khwarizmi a little bit. So he lived between 780 and 850 AD, so quite a long time ago, and was a polymath who worked in the House of Wisdom in Baghdad. And he's thought to have been Persian, originating in that area of Greater Iran, which we now call roughly Uzbekistan and Turkmenistan. And I've linked an article below for more info and all of those details about this guy, because he is so cool. Not only was he a mathematician, he was an astronomer, a geographer, a scientist, a linguist, and an astrologer. Right? There is so much cool stuff to learn about him. I highly recommend you go have a read. And yet we hardly ever talk about him at school. Yet how many times do we talk about Ford or Newton or Edison? You know, like, what about this guy? He wrote the key manuscripts that made algebra universally applicable in ways that people like Ford and scientists and mathematicians are using today, as well as programmers, like I said, working on algorithms for research, robotics, and AI. And in fact, like I said at the very beginning, the word algorithm comes from the Latinization and then eventually anglicized version of the Latin for al-Khwarizmi's name. Al-Khwarizmi, algorithm, right? He did not invent algebra or even numeric system that we use today, but what he did was translated it and developed it, like many Islamic scholars at the time were doing this during the time period known as the Golden Age of Islam. They did so much hard work translating knowledge from even more ancient scholars, Babylonian, Hindu, and Greek scholars, and their work allowed eventually that to be translated into Latin and Greek, and that work passed through into Europe, and I say passed through, was taken into Europe by European scholars and contributed to developing the systems of maths and science as we know them in the global north today. And so what he did was added his perspective to the earlier works. Like Ford, he developed the system that already existed into an applicable real life problem solving tool for problems that people had at the time. His techniques, his notation, and his work on things like the number zero, for example, which I talked about last week or the week before, as well as balancing equations, this revolutionized mathematics, advancing it from just simple arithmetic or calculations, and it took it to the next level, all because he had this excellent algebraic thinking. He turned what would have been really complicated problems for the arithmetic methods of the time, think stuff like abacuses and counting systems, he turned these problems into easily solved equations that relied on the abstracted concept, and he used words and diagrams to solve and balance problems. And we use those exact concepts today. So what we call simplifying expressions, he called reduction. Moving a negative quantity from one side to the other and then changing its sign, he called that completion. And subtracting a quantity from both sides, he called that balancing. These are all techniques you learn in your first algebra class, yet I bet you had no idea that they were 1200 years old, right? How cool is that? Al-Khwarizmi's work was so powerful because not only did he provide novel techniques for solving complex polynomials and other real-life specific problems, like I mentioned, he solved problems around inheritance, dividing up land, trade, surveying problems, all sorts, into abstractly conceptualized algebraic problems where you have the same set of steps that you can follow each time, no matter what the specific numbers were. And that meant that he was providing people with a framework that they could use themselves for solving what writers Rashed and Armstrong, I've linked them below, have a look, they called this an infinite class of problems. He truly was a savant. This was an incredible development. And he is also the reason that we use the technique completing the square, if you've revised that yet, to solve quadratic equations. And he's also credited with developing the lattice multiplication method for big numbers, which Fibonacci then brought into Europe, which you've already hopefully seen my short videos on that. Slightly different, it's a modification. Anyway, other incredible achievements of his, he made an incredibly accurate map of the Nile, North Asia, Europe, North Africa. He produced accurate sine and cosine tables. He produced the first ever table of tangents. He figured out how to find the coordinates of the sun and moon using the Hebrew calendar. And he wrote 2 books on using and constructing astrolabes. And if you don't know what an astrolabe is, I'll chuck up some images on the screen here so you can see. Just think the big golden brassy spherical turning things that look like a cross between a globe and a sundial and some kind of grand device that you see in every steampunk or fantasy setting whenever you walk into like a wizard's tower. It's, you know, one of those things, and they spin and turn and look cool. He also wrote Political histories where he included horoscopes for significant people, and that's quite fun. I find that quite funny. I love astrology myself, and I enjoy reading how many famous ancient scholars included it in their skill set, like totally legit with all their other skills. Um, that tickles me, and if that doesn't give away what star sign I am, um, leave your thoughts in the comments below if any astrologers are listening. Anyway, back to the point. Al-Khwarizmi's development of problem solving used the same repeated set of steps regardless of the numerical aspects, and that's what led us to being able to program computers to solve equations for us, right? And algorithms that we all interact with every day. Imagine if instead of solving issues of inheritance or what the specific coordinates of Mecca are, if al-Khwarizmi, the father of algebra, knew that his work was determining what videos we watch every day, what news we hear, what products we're buying, and what trends are capturing popular imagination. I wonder if he knew, if he could foresee the power of the problem solving system that he translated and developed. Like, that would surely blow his mind, or like maybe he knew, maybe he could tell how powerful what he was doing was. I don't know. But anyway, hopefully that inspires you to think a little more abstractly and in steps when you're tackling your algebra problems. That's really the key. When you consider what the components are, that you're following the same set of instructions every time, if you can turn every single math problem you're solving into an algorithm, and then you recognize the clues in exam questions, and this is what I was talking about in my very first video, you've got to know the steps. If you can see the clues that trigger a certain algorithm, you're going to get all the marks, because then it's just chucking numbers in, right? And also, I hope today's video has helped you consider what and whose stories are told about technological, scientific, and intellectual advancements, particularly in the 20th century. But that's more than enough politics and history for today. So if this interested you, all the links to the sources and everything I talked about is below. YouTube is also full of videos about algebra, algorithms, and ancient mathematicians and their stories. So if you want to know more, have a Google of any of those things I saw. Maybe I'll link that below as well. A great video about algorithms recently, how they work and what they are and stuff. For now, I'm just going to leave you with a reminder that your words are spells, so be kind to yourself. Have a lovely rest of your day. This week's physics and chemistry videos are being uploaded really soon in the usual place, linked below. Thank you for being patient with me this week while I had a down week. The stuff happening in the world and my life were getting on top of me, and I just needed a break over the weekend. But that'll do for now. See you next time. Yalla, bye.